In this problem, we're dealing with air that's placed in a piston cylinder apparatus. The air is trapped inside the piston cylinder apparatus at 0 degrees Celsius, and at that circumstance and under those conditions, the volume is 6.83 centimeters cubed. The question is, at what temperature in degrees Celsius would the volume be 9.75 centimeters cubed? So this is a gas law problem that involves a change, and therefore we may start with the combined gas law equation, P1 V1 over N1 T1 equals P2 V2 over N2 T2, and cross out everything that's constant. At this point, the pressure on the system is P atmosphere. That's the same for both of them, so the pressure P1 is equal to the pressure P2, so those pressures will cancel out. Also, the number of moles of gas doesn't change as we change the temperature, so N1 equals N2, and we can cancel those out, and our equation becomes V1 over T1 is equal to V2 over T2. Now here, we're asked to solve for T2, and T2 would be equal to T1 times V2 over V1. So let's look at the variables. T1 is 0 degrees Celsius, and that would of course be 0 plus 273 or 273 kelvins. We have to express the temperature in gas law problems on the Kelvin scale. V1 is of course 6.83 cubic centimeters. T2 is the unknown variable. We don't know what that is. And V2 is equal to 9.75 cubic centimeters. So if we plug into the equation that we arranged down here, T2 would be equal to T1, which is 273, times the ratio of V2, 9.75 centimeters cubed, over 6.83 centimeters cubed. And you can see the centimeters cubed are going to cancel. This is just a conversion factor, and this will give us about 390 Kelvin for T2. But the answer needs to be in degrees Celsius, so 390 kelvins minus 273 is 117 degrees Celsius. So we convert the temperatures first into kelvins. We carry out the calculation to determine T2 in kelvins, and then we subtract 273 to put it back into Celsius temperature. And notice that the volume goes up as the temperature goes up, which is the way that it should be. Volume is directly proportional to temperature according to Charles's law.